In this nugget, you will learn about remote sensing images and how they provide meaningful land cover information. Remote sensing is a process of monitoring surface reflectance of Earth from measurements taken from drones, planes or satellites. In remote sensing, the reflected or emitted radiation of different wavelengths are captured. The sensors measure an electric signal proportional to the radiation received. Each wavelength provides different information about the land surface. The animation here shows how this works. Remote sensing images have wide range of applications, which include environmental monitoring, disaster prevention, land cover mapping and more. Thus, analyzing images are important. Here, we will focus on land cover images from satellites. There are several satellite missions dedicated to observing the Earth's surface. For example, Sentinel-2 from ESA and MODIS and Landsat from NASA. All the data from these satellites are openly available for public use. For the purpose of this course, you will use Sentinel-2. Similar principles can be applied to other data sources too. Let's go deeper into Sentinel-2. Sentinel-2 is a constellation of two satellites, 2A and 2B, and is thus called a twin satellite mission. Sentinel-2 was launched in 2015. The two satellites cover the whole globe every 5 days. The animation here provides a good view of Sentinel-2's flight track. The Sentinel-2 multispectral instrument has 13 bands. It measures in the wavelength range from 440 nanometer to 2200 nanometer as shown here, thus capturing a lot of information about the land. Bands of different wavelengths are used for different purposes. There are bands measuring aerosols, short-wave infrared bands. Some bands even measure cirrus clouds. You will focus on 4 bands, that is 3 bands in the visible spectrum, red, green and blue, and the near infrared band. These channels provide important information about the land surface properties. In particular, the near infrared band gives you information about the vegetation, as healthy plants reflect more NIR compared to plants which are dying. Near infrared reflection is also powerful in distinguishing between land types, water and vegetation. Here is an example of 4-channel image. Natural images are displayed with the 3 color channels, red, green and blue. So, how do you display an image with 4 channels? One solution is to visualize it in 2 different scales. Besides the RGB image which shows the visual texture and patterns, you can also visualize near infrared red-green scale. NIR readings are displayed in red, the red color is displayed in green and the green color is displayed in blue. In this final section, I will tell you about a property called pixel resolution, which applies to all bands. As Sentinel-2 image covers huge part of the land, hence it is important to know how coarse or fine are the images. Pixel resolution are measured in meters. 10 meter pixel means a pixel grid covering 100 square meter, that is 10 meter cross 10 meter. Sentinel-2 has different resolution for different bands. There exist bands with 10 meter, 20 meter and 60 meter resolution. Fortunately, the 4 bands which you will explore in this nugget are of 10 meter resolution. In the case of varying resolution, you need to apply interpolation techniques on the coarser band to maintain the same resolution throughout all bands. In this nugget, you will use the pillow module of Python to view images. Such images take data type floats or unsigned integer 8 to produce a visual plot, but the readings from Sentinel-2 are measured in different units. They use integers varying from 0 to 10,000. Hence, in practice, you have to divide your measurement signals by 10,000 in order to process images through functions in the pillow package. Please note that sometimes the picture will look very dark, so when readings are not visible, please scale the readings. Generally, scaling by 2 will be sufficient. It displays a brighter picture.